Alright, welcome to Doozer Shop. I'm going to do an update on the Colchester lathe. Let me pick up the camera and we'll look at what I've been doing to the Colchester lathe apron. Get the lathe back together project. Alright, so let's see. The last time we were looking at this, and you know, I should have prepared before I just up and film this. Alright, so this is what I call the rocker box. And I'm going to go around here. I'm going to put my finger here without. So that's how this works. So there's a brass plunger in there. And what happens, disengage now, the gear teeth are enmeshed. To disengage it, the handle compresses the spring, pulls the brass plunger in, and that's how it works. So it's never going to go this full back. So this spins the worm gear, and the worm gear meshes with either the cross feed or the long, bed feed. So let me spin the camera around. So this plunger, I made a new one. This is 954 aluminum bronze. And there's a step in it, so it fits real tight. All right, it fits with like a 5/1000 slip fit in the bore. And this diameter that's turned down controls the amount of gear mesh from the worm to the worm wheel. Okay, now the deal is this. So this is the slot for the handle, and this is the counter bore for the plunger, the detent plunger. I know I call things a few different things here. So the plunger or the detent clicks into that counter bore, and the slot is for the handle. So that's the diameter that this originally was the same size, and it wasn't stepped down, and the gears would mesh too tight. Okay, now you see these bushings, that bushing and that bushing, this lathe, I don't believe, and please people with a Colchester 17 correct me, were never in there. The previous owner before me, or somebody along the history of this lathe, bored these iron castings out to accept bronze bushings. And to my knowledge, this was just running in the iron casting, so somebody added this bushing, and someone added that bushing, and someone bored out the apron casting and added that bushing. So what I'm thinking is that whoever bored these was off just a bit. I think it's off like 5/1000 in height. And the problem is, close the drawer here, that when that worm meshes with that wheel, like I said, it was just barely not clicking in that counterboard recess, and it was causing the gear teeth to mesh so tight with no backlash at all. So that was an issue. So that's what I did is I turned because the original one was hardened steel, and it's over sitting on the lathe. Instead of modifying that, I made one out of bronze, okay? So that's why, and actually I made it a little tighter fit, 5 thou clearance fit in this, the rocker box bore. So it's a nice tight 5 thou slip fit, but it's actually turned down to fit these counterbore recesses. Now, the diameter of these counterbore recesses is 1 inch, 145 thousandths. So a little bit over 1.125 inches. 1 inch, 145. Now the diameter to this, where it's turned down, is I think is 1 inch, and I think it's like 45 thousandths. So it's 100 thousandths less, okay, on the diameter. So that's 50 thousandths on the radius less, okay? So when this rocker box would click in, well, it wouldn't click in. It was 50 thousandths too high, and it was gear to gear, okay? So what was causing it to be too high and not click in was the worm gear was physically crashing in to the mesh of the worm wheel, or the driven gear, okay? So by making this new bronze detent plunger, and like I say, I snuck up on it on the lathe. I was putting it in and out of the lathe, taking 10 thou off, trying it, taking 10 thou off, trying it, taking 10 thou. You get the idea. Like I said, it's about 100 thousandths less in diameter than it originally was. So it's 50 thousandths on the radius. So this rocker box was sitting 50 thousandths too high for the detent plunger to click in to the counterboard pocket. So now it works really awesomely well. Okay, well, yeah, it works really sweet. So that's the cross slide. Okay, and then this is upside down, mind you, and there's no limiter. There'd be I'm going to build a limiter piece. Let me move this over to this side, and then it drops in. Now that's the bed feed, the longitudinal feed. Okay? So that's how that works, and that is working very well. And like I said, this yellow thing keeps the half nuts from being engaged when the power feed is engaged. See that? So that screw is just a limiter to prevent it from falling, you know, out the bottom, because this is upside down. And the fact that that hits that, there's like a flat on this shaft, and then it just won't let it won't let the half nuts drop in. So that's cool. That's what that's about. Some of you guys were wondering about that. Okay, so one of the challenges I had is because that gear is brand new, because the old one had some teeth missing. So I bought a new gear from Frank Kleinworth in Texas, and he could have got me a Clausing Colchester gear, or he had a local machine shop making these as a little money saver. So I think I saved $200 by buying Frank's replacement gear. But anyways, that's a brand new gear. And let me open this back up and kind of show you guys. All right, let me get the flashlight going here. All right, that's the original gear. That is the original gear for the bed feed, and that is the new gear. Okay. So the gear for the bed feed is worn a little bit. It's got the radius of the worm worn in a little bit, just because, you know, this is an old lathe. So consequently, the worm would drop into mesh a little bit deeper on the old gear, which is for the bed feed, the longitudinal feed, and it would drop in a little less and consequently be shallow, more shallow on the brand new gear. So what would happen is, you know, in that detent there, in the counterbore for the detent, that one would drop in when I was trimming the diameter away and cutting and fitting, and then this one, it wouldn't. And I'm like, what's going on? So really what I ended up doing is that counterbore for the detent, I thought, man, I gotta grind it off. Put the flashlight away. I gotta grind it like taller, and I was looking for, you know, carbide burrs for the die grinder or grinding stones, just to massage it a little bit. And I'm talking like it needed 10th thou or something, folks, not much. Because like I said, that gear is new, and it caused, you know, the worm wheel to sit a little higher. So I got the plunger, the detent plunger turned down, fitting with good clearance, and I was able to, you know, stick my fingers underneath while this was closed and spin it, and everything would spin nice, and it would drop in and spin fine there. And I could actually get it to engage and drop in there, but it was still so tight I couldn't reach around and I couldn't spin the worm because the mesh was just too tight. So I needed to grind that out, and then I was, you know, grinding dust, and I wanted a grinding stone or a carbide burr approximately that size, like 1.125 would be perfect. Like I said, that was the actual measurement of that diameter is 1 inch 145. So I did some hunting, and let me show you what I came up with here. All right, so this is my drawer full of well, milling cutters and all kinds of stuff, and I had a woodruff key cutter, okay, for cutting woodruff keys and shafts. And this actually, can I see? You probably can't see. Was written on it somewhere. Oh, it's rusty. You probably can't read it. But it's an 1.125 cutter. So I'm like, jam up. This is awesome. So what I did is, I'll show you. I put it in, and it fits. It fits really perfect. And so perfect that, like I said, my counterbore is 1.145, and this actually measures 1.140, so it's 5 thou smaller than that counterbore. And for whatever reason, they're calling it an 1.125 cutter, but it's oversized. It's actually 1 inch 140, and I've got a 1 inch 145 hole. So I says, holy smokes, it was meant to be. So that drops in there. So what I did is I don't laugh. I really thought about this. I took the battery drill, I chucked this up in my DeWalt battery drill. And I had the drill back here, and I had this thing, and I started spinning it. I put it in, you know, in low gear mode, and I was holding it, and I just was putting upward pressure on it while it was spinning, and it was generating cast iron dust, just, you know, spinning it, spinning it in the proper direction, Dan. And I took 10 thousandths off the top of that by spinning a wood rough cutter in a battery drill. Yes, I know it sounds very backyardish, but it worked super well. And I was able to get my detent plunger to drop in, and it was hugging the top. Well, before it was hugging the top, now it actually drops in, and you could actually have some. Gravity was holding this down, right? Okay, let me put this back in. And what you can do is, you can hear I'm lifting up on it. Actually, I had a dial indicator base mounted here, and I was measuring the backlash with the indicator mag base on here and the tip of the indicator touching the apron wall. I'd lift up on it, and I'd measure the backlash there, and I'd measure the backlash with it over here. And like I said, I got this so it drops in just nice. Let me just set that. And you could reach around underneath and you could spin. You got to hold it up and spin it. See, I'm holding it up. And you can spin the gear all the way around, 360 plus degrees. And it works. It works there and it works there. I don't even know if I could do it here. Maybe, I don't know. Maybe. For the sake of the video, I can't lift up and, yeah, I can a little bit. Like, I got to lift up and spin it. But it works. Okay? So that's that. Crazy, I know. Let me take this off. Alright. So one more thing I got to do. So I got a ground spacer washer over there. And you know my bushings stick out more than normal because more bearing is more better. So when that bushing contacts that spacer washer, it is perfectly lined up to drop in there. Now when it's over here, I know you guys love this. There's nothing over here yet. I got to cut a spacer. I'm thinking this is an 1.25" shaft. I'm thinking schedule 80 1.25" PVC plastic pipe would maybe be a good fit. I've got extra bushing. So I originally had a cast iron spacer, but it's a little short, you know. And I could make another additional extension bushing. I don't know. It doesn't hurt having two things sliding around on there. I'd rather have one. And the plastic idea, PVC might act as a little cushion. Slamming it down. It's really odd to have this rocker box. See, to me, this is like a Norton quick change rocker. You know. But anyways, I call it a rocker box. So let me take this up. Let me slam it down. Alright, so it's just going to stay there. So just so you guys can see, there's the half nuts, and this thing will pop up. I hope I'm not shaking the camera too much. So this kind of lean down here. This, you can see my lever, this all works very well. See? It's awesome. So, let's see here. See if I can. So there's a little detent recess there. Inside here is a spring. You may not be able to hear it. It clicks in and there's one up there, it clicks in up top. Okay, so there's a spring in there and a ball. And here's my collection, so of different, just say no to vertical video, folks. So I've got some 1/4" balls, and I threw my springs in here too. That's a 1/4" or just under 1/4" outside diameter spring. And it worked pretty well. I wanted some more force to the detent. And then I found these little springs that actually fit inside the big spring. And they're actually pretty thick wound wire. So I got one of these springs inside one of these springs pushing on a 1/4" ball inside the handle. And that works very well. It's got a good amount of, it's got the perfect amount of tension, in my opinion. And I greased the springs up with Vaseline to lubricate them. I guess greased is a verb, and I didn't use grease. I used Vaseline petroleum jelly, which is, Vaseline's a brand name, but whatever. So I got my, this is the feed shaft right from the lathe, and I got this all on the workbench, and I'm mocking it up with the actual feed shaft, feed rod. So as you can see, geez, let me back up. That's actually the cross slide from the lathe. Been sitting on the workbench for like 6 months plus. I got a piece of wood, and then I got another piece of aluminum as a spacer to space this thing perfect. And I got an apron on blocks of wood with spacers, and all this monkey business is to fit the rocker box and all the associated goodness that I'm showing you guys here. Jolly good. Okay. All right. Ooh, it's a six pack of calipers. Look at that. So, long and short, yeah, it was handy to have that. So, all right. More tools than sense. All right, so I guess that's kind of it. Let's see. What I do last night. Also, so that bolt comes from the front of the apron, and that prevents this from dropping down. And well, the half nuts are engaged. Okay. So this bolt keeps this from falling down. And it was hitting the rocker casting. So what I did last night, let me zoom you around. I clamped this in the Kurt vise in the mill, and I used an end mill, and I clearanced it. I just kind of marked it on the paint, and so that doesn't interfere any longer. And this worm, had a little bit of see, this is a steel worm, and the gears, the worm wheels are iron, cast iron. But from years of use and abuse and non-lubrication, there was a little bit of metal transfer on the teeth there. So I've been stoning. I got these like India stones rather, and I've been working polishing the worm till my fingers hurt. Yeah. So interestingly enough, that diamond shape India stone is very handy, and it just happens to be sitting here. This needle file is a diamond shape also, and I use these for filing boogered up threads. And it's not intended as a thread file, and it's narrower more narrow than a 60-degree thread form, but it's nice because it gets down to the root of the thread. And I forget the name of this file. It's a parting file? Maybe a parting file? It's not a warding file for warding. I think a warding file, I think warding has to do with key locks, lock sets, something. I think that's a parting file. I don't remember. But you know what? I broke one, and it was like, I used this, I broke one. This is a while back. I think I broke it. I dropped it on the floor or something. I wasn't abusing it. I just was careless. So I went on eBay. Well, actually, I went on McMaster Car's website to find out what the heck this shape was called. And then I found them on eBay pretty cheap. Well, I think I bought 5 of them. 5 of them for like 20 bucks and then $5 shipping. So a little more than $5 a piece. But they are just so handy for filing threads without getting too aggressive with the sides of the threads. I can clean the roots out without splaying the thread any wider because, like I said, it's a little bit sharper an angle than a typical 60-degree thread. Okay, so yeah, mishmash, soup to nuts. I kind of cover a lot of different stuff when I have my videos with you guys. I think what I'm going to do is use 90-degree push lock fittings to go to 1/4-inch flexible hose instead of these elbows. And I might, you know, because this moves, I might put my oil cups on the front of the apron. I'll show you that in a later video. Whatever. But so I know this is a long video, but that's my latest I've been working on, and you can see over on the I cleaned the chip pan on the Sagami lathe. This thing was full of bronze chips, man. That's actually that's another bar of bronze right there. I think it's 1 5/8 diameter solid bronze, 954 bronze. Was talking to my buddy Mark about Brown and Sharp screws. All those are Brown and Sharp screws from the Brown and Sharp 13 grinder. And when I was rebuilding the grinder, if I could replace it with an Allen head screw, I kind of did. And these are the hex-headed Brown and Sharp screws. And they're all normal pitch. But they're slot heads. And the only saving grace is that they are hard as can be. I mean, these are like Rockwell 58, man, on the C scale. These are hard, hard, hard. I tried turning a head diameter smaller with carbide, and it didn't even like it. These could be 60 Rockwell, man. These are just crazy hard. But anyways, so been busy doing that. Not much else. Clean the SIP up. Been working in the closing 8520 mill. I think I got it vacuumed up too. So I've been working, milling, cleaning. Man, the shop vac is an essential accessory. But oh, somebody commented in my videos about, they said, hey Doozer, nice parts washer. So let me do a quick little, okay, forgive the cardboard stuck there. That's a, I think that's a 45 gallon drum. Not a 55, a 45. And I got it on, the red thing is a roll around drum caddy, so it's got wheels. It's got a switch on the side. It's got a little giant peerless pump inside. Geez, I don't know if I can. No. Let me see. Just for my viewers. All right, there's where it goes down into the tank. There's the power cord. So that's a 3/8 elbow, 3/8 pipe thread elbow. And that's a 3/8, that's a fitting. It's a cord grip compression fitting to a rubber cord. So that's from, SO cord, rubber grip fitting to a 3/8 pipe thread, 3/8. 3/8 elbow, and that's a 3/8 pipe. So that 3/8 pipe goes down into the tank. And there's a female 3/8, no, what is it? I think it's a 1/2-inch fitting. I think it's a 1/2-inch male fitting on the pump. Okay? 1/2-inch pipe thread. 1/2-inch male pipe thread fitting on the pump. And I have a reducer bushing to reduce the 1/2-inch pipe thread fitting on the pump to 3/8 pipe thread. And this is a 3/8 pipe that is, however long that goes down, it's probably like 2 foot, okay? So the pump's in the bottom, and so the reason this pipe, I use 3/8 pipe, is just like that is an SO cord grip compression fitting. This is also a cord grip compression fitting. Okay, so that is 3/4 pipe thread. Okay, that's a 3/4 pipe thread. I guess let's call it a bung welded into the lid of the tank. I think I TIG welded it in there, cut it in with a hole saw. That's actually probably just a union fitting. A coupling fitting. Okay, that's a coupling fitting, 3/4 inch pipe thread, and that's a cord grip. And it's not gripping on a cord now; it's gripping on a piece of 3/8 pipe, right? And it's, okay, Doozer's bandsaw. This it's basically one of these. It's a cord grip, rubber cord grip fitting. And you can see how fat this 3-phase line cord is. This is SO or SJO. It's actually SO, service cord. O is oil resistant. If it was SJO, it'd be junior. Okay, and what junior means is it's 300 volt, not 600 volt. Okay, that's whatever. So that's that. So that's how my pump works, and you can loosen that and bring the pump up off the bottom a little bit. Okay. So here's the piece of this is automatic transmission cooler hose, 3/8, and it just comes out of the tank. Drill the hole in the tank and comes out. Okay, let me back up here. And comes into a hose barb fitting and an elbow. And this is a water filter, a home water filter. Okay, and you can put the cartridges in there. So I'm running mineral spirits. This is some kind of plastic housing. It does not leak at all, and it's elbowed. I think that's 3/4 again, elbowed up, and there's some kind of union fitting, and it goes into that faucet. Okay? And that faucet has the line lock tubing on it. And I think I soldered a fitting on the tap of the faucet to convert it to, I think that's 3/8 pipe thread again, where that line lock thing goes. I have a shelf on there, a blue shelf, and my oil cans hang there. And the shelf I just milled a slot in there and it kind of hangs. This shelf is from a slat wall in a retail store, and that would normally go into a slat wall. But I just milled a hole, and this is a scrap piece of steel, and it's got miscellaneous holes in it, and it's just TIG welded to another piece of plate, and this plate you can see was kind of rusty, and I think it had 3 holes in the sink for a sink faucet, like a kitchen sink faucet, and I used them holes. I got 1/4-inch Allen screws there, and there to go through, you know, the sinkholes. I'm gonna make a video on sinkholes, not today. And I think there's another bar on the bottom to sandwich it. So, I know it's a lot of explanation. Oh, and that's the wrench for taking the filter off. That's just the filter wrench that unscrews. And all this is just kind of held by that faucet fitting. So anyways, so that's the parts washer. That's the parts washer, and the top is handy. I got my oil stones there, and some wire brushes, brass brushes, nylon brushes, little nose picking tools, and all kinds of brushes. So that's pretty handy. So let's turn it on. All right, and that's it. And it's, it's just a kitchen sink. And with the line lock hose, it's, let me get down. Now, both in the shot. That's full bore. You can turn it right off. So that regulates it with the faucet. I know it looks goofy, but it does work, and it does not leak. I probably put new packing in it. And it, it's fine. Works really well, all right? All right, so at the request of one of my viewers, that's the parts washer tank. I think I paid $85 for the pump. I got the sink for like $5 at a friend of mine's junkyard, or maybe he even gave it to me. I forget which. I think I put some like rubber edge guard on there, But like I said, this shelf is essential because you always need. You got brushes and little scrapey tools, and I do all my stoning inside the parts tank because that way it keeps the stones nice and clean. The mineral spirits does. So this is a long one, shooting the poop in the shop here. Yeah, parts washer. Thanks for your interest in Doozer shop tools. So, like I said, that's the progress on the apron. I'm probably going to make next that spacer bushing that keeps the rocker box from coming over too far and keeps it lined up with that slot. You see my little my wood rough cutter affair with the bet. It sounds hacky, but it worked really well. So the next thing I'm going to do is I'm going to get some flat steel, some flat iron. I'm going to make a bracket that bolts onto these 2 holes on the front of the apron, goes down, over, and connects to those 2 holes there. That limits the drop of the handle, okay? So it doesn't swing like all the way down where it's sitting now. All right, that's going to be a wrap. Until next time, this has been Doozer Shop.